Hello students, welcome to the CBSE Chemistry lecture series. In the last video we discussed the colligative properties like lowering of vapor pressure, elevation and boiling point. These two properties we discussed already in the previous videos. Now we are going to discuss the third property, depression in freezing point. So what is a freezing point? First we have to define what is meant by freezing point. The freezing point of the substance is the temperature at which the liquid and the solid phase are equal. Freezing point of substance is what? Is the temperature at which the solid and liquid phases or vapor pressure of the solid and liquid are equal. That is called freezing point of a substance. So let me explain with the help of a graphical representation. Say for example, temperature increases in this manner and the vapor pressure increases on vertical. Suppose if a pure liquid solvent, say for example A, so the point B and point C. So this is for what? Pure liquid solvent. Suppose if it is a solution is there, it will be still lower than this one. You have to note down this temperature. This is for what? Pure solvent T0, and there is a freezing point of a solution is what? This is what? T, solution. So you can say A, B, C curves and D, E curves. Okay. So in this case, I will discuss a curve on cooling the vapor pressure of the liquid solvent along the curve A and B. At particular point B, the solid starts freezing, or you can say solid starts appearing and the vapor pressure decreases steeply towards the C. So this particular point B is the freezing point of a pure solvent. At point B, that is the freezing point of a pure solvent. We can note as what? T0. And the solution, this is for solution. The solution still deeply decreases at the point E, starts solid appearing on that one. So at E, the freezing point of a solution is T. And find out the difference. Delta TF is what? T0 minus T. This difference, that is called delta TF. The F stands for freezing point. And if it is a delta TF is directly proportional to molality of the substance. So delta TF proportional to say you would put a constant that is called Kf into M, where Kf is known as, and the last class Kb is what? Ebullioscopic constant. Here it is what? Cryoscopic constant. Cryoscopic constant, or otherwise known as molar depression constant. Molar depression constant. Yes. By the freezing point graphical representations, we can calculate two things. One, calculation of molar depression constant, that is Kf, from enthalpy of fusion. From enthalpy of fusion. That is one. The second thing, calculation of molar mass of a solute. These two things we are going to calculate by using this depression freezing point. Suppose if it is a depression freezing point, Kf is nothing but the gas constant and the pure solvent whole square divided by 1000 into LF. LF stands for latent heat of fusion of ice, where latent heat of fusion of ice is nothing but delta H of fusion of ice by M1. You can substitute here in the place of LF. So Kf is equal to R T0 whole square by 1000 into what is LF here? Delta H into M1. If you substitute all these values, like what? The R value generally is 8.314. If it is a energy, or you can say joules, if you want to express that R value. If we want to express the R value, we can also express in calories per degree per mole. That is what? A 1.97 that we can take as approximately 2 calories per degree per mole. Okay, and that M1 of a substance is what? Nothing but 18. And the T0 for a pure solvent, that is 273 Kelvin. And the latent heat of fusion of ice is nothing, that is delta H of fusion is what? Is 1436.6. If we substitute all these values in this formula, 2 into 273 whole square divided by 1000 into 1436.6. If we substitute all these values, we are getting a 1.87 Kelvin kilogram per mole. So this is a Kf for water. Normally in the textbook they are given as a 1.86 is a constant for water, depression constant for water. So at the same time, by using this formula, we can also calculate the molecular mass of a solute. How can you calculate the molecular mass of a solute? So in this case, delta Tf is directly proportional to molality of the substance. Delta Tf is nothing but Kf into M. Whereas in this case, if you want to find out a molar mass of a solute, you have to know what is the definition for molality. Molality is nothing but number of moles of solute in 1 kilogram of solvent, that is W2 by U, using the formula 1000 by W1 gram. If you want to find out the molar mass of a solute, then you have to say M2 is equal to Kf into W2 by delta Tf into 1000 by W1 grams. This is the formula for calculating the molar mass of a solute. So this is a concept. Based on this concept, we are going to work it out. Yes, we will take this NCERT in-text problems. 2.11. Calculate the mass of ascorbic acid, that is other name for vitamin C, chemical name for vitamin C. Its molecular formula is given as C6H8O6, to be dissolved in 75 gram of acetic acid to lower its melting point by 1.5 degrees centigrade. If Kf for the solvent is 3.9 into Kelvin kilogram per mole. So this is the data available. Given data you are right. What are the data available here? Kf is given as 3.9 and what other things is there? Calculate the mass of ascorbic acid. Ascorbic acid is a solute here. W2 is equal to question mark, and M2 they are given a formula C6H8O6. You got to 6 into 12 72 plus 8 hydrogen, 8 into 1 8 plus 6 into 16, that is 96. 176 is the molar mass of the ascorbic acid, and that molar mass of acetic acid is CH3 COOH that is equal to 60, and W1 is 75 gram. So these are the data available from this problem, and delta TF is also given as 1.5 degrees centigrade. You just simplify what? Substitute the things. Delta TF is equal to KF into W2 by M2 into 1000 divided by W1 grams. This is the formula is given. So you have to calculate that what? W2 only you are going to calculate. So W2 is equal to cross multiplications delta TF into M2 into W1 by KF into 1000. Yes, now you got to substitute the values here. Delta TF is equal 1.5 into M2 is given 176 into W1 is also given as 75 grams and divided by KF is what? 3.9. It is given here into 1000. It is a direct substitution problem. If you solve this one, we are getting a value of 5.07 gram. That is W2, or you can say mass of ascorbic acid. That's the answer. Yes, another problem related to this depression freezing point. This is for practice. A solution of urea in water has a boiling point of 100.128 degrees centigrade. Calculate the freezing point of a same solution. Molar constants for water and for water, they are given a KF as well as KB values. Depression constant is 1.86 and molar when say what? Molar constant for boiling is 0.52 degrees centigrade. So these are the data given here. So we have to calculate the freezing point of a solutions we have to find. There are two steps in this one. The step 1, you have to calculate the molality from the boiling point data. To calculate the molality from boiling point data. That means what is given here, given data for this case? Delta TB is what? 100.128 degrees centigrade minus that what? 100 degrees centigrade, which is a 0.18 degrees centigrade. Okay, using the formula. What is the formula for this one? Delta TB, you have to use it, is equal to KB into molality of the substance, where if you want to find out the molality is equal to delta TB by KB, that is 0.128 divided by, here it is what? It is 512 degrees centigrade. So you have to 512 degrees centigrade. So if you substitute this, if you want to simplify this one, we are getting a 0.25 molality of the substance. The step 2, what you have to find out? The step 2, calculate the depression constant. Calculate the depression freezing point. Calculation of depression in freezing point. How can you calculate the depression freezing point? So you have to use it what? Delta TF is equal to KF into M. KF is given as what? 1.86 into molality you have find out for the same solution, so you have to take this one 0.25 M. We can get a value of 0.465. So then you have to find out that one delta TF is nothing but T0 minus T. The question is what? Calculate the freezing point in solution you have to find out. So you have to bring here T is equal to T0 minus delta TF. T0 is what? It is nothing but 0 degrees centigrade minus this 0.465. So net value is what? Minus 0.465 degrees centigrade. That is the answer for these solutions. Thank you, students. If you have any questions, please mention in the comment box. Next class we will see that one. Thank you, students.